Okay, guys, so 7.2a lesson, we are dipping into this two-dimensional shape and looking at what happens if we slice through them, what 2D shape will form when that happens. So we're going to need a website to kind of get our head around this that I'll kind of be bouncing back and forth between. Okay, so let's take a look at a cube. Okay, let me get my cube. Where's my cube? I don't have my cube here. Okay, so I've got my cube. Okay, if I have this cube sitting flat on a table or on your hand, and I cut, so this is its base down here, and I cut parallel to the base. So pretend that you're like a ninja and you've got a big long sword and you slice parallel through this object. Let's sketch the exposed surface. Okay, so parallel would kind of go through it like that. Okay, and you would see, okay, you always get a cross section. Cross, let me put the other word there, cross section, plane section, those are synonyms, okay? You always get a cross section, plane section, you might see planar section, okay, which is always a square. Okay, so it's super important to understand if you have the shape and you make that parallel slice, it's going to be the same exact exposed sketch here, no matter if I cut it really low or if I cut it really high up on the shape. It's going to be the exact same square, okay? All right, number 2, cut parallel to the base again, but at a different distance. Oh, I just kind of spoiled that one. Okay, so it doesn't matter. We're still going to get that square shape. Okay, so if I cut parallel but just higher up this time, I still get this shape. And let me kind of go like this because this one looks like a square, but this one kind of doesn't. All right, so how does the new exposed surface compare to the previous surface? It's the same. It is the same. A cut perpendicular to the base and parallel to a face. Okay, so perpendicular to this thing would be straight down at a 90-degree angle, straight down, not at a slant, a slope of any kind, just straight down. Okay, so straight down, we would still get this square. Okay, you always will get a surface that is the same as the face of a cube. Okay, number 4, cut perpendicular to the base and parallel to a face again, but at a different location on the cube. Okay, let's just say that we slice through closer instead of right through the middle. We cut closer to the edge. Okay, so you're still going to get that square planar figure. Okay, so we can conclude that all plane sections parallel to a face will be a square. Okay, so the definition of a cross section is a two-dimensional shape that is revealed when a planar cut is made through a solid three-dimensional shape. So that's the official definition. Okay, so we're going to watch a video on cross sections of a cube, and then what other cross sections of a cube are possible, show and or explain the types of cuts you need to make for each cross section.
Well, imagine if that plane were to cut just like this. A square is maybe the most obvious one. So it cuts the top right over there, cuts the top right over there, cuts this side right over here, cuts this side right. This video is explore the types of two-dimensional shapes we can construct by taking planar slices of cubes. So what am I talking about? Well, let's say we wanted to construct a square. How could we slice a cube with a plane to get the intersection of this cube and that plane to be a square? Well, imagine if that plane were to cut just like this. A square is maybe the most obvious one. So it cuts the top right over there, cuts the top right over there, cuts this side right over here, cuts this side right over here. It cuts this side, I guess in the back, if it's a glass cube, you'd be able to see it, right over there, dotted line, and then it cuts this right over here. So you can imagine a plane that did this. And if I wanted to draw the broader plane, I could draw it like this. Let me see if I can do an adequate job of drawing the actual, I guess you could say, part of the plane that is cutting this cube. It could look something like this. And I can even color in the part of the plane that you could actually see if the cube were opaque, if you couldn't see through it. And actually, but if you could see it through it, you'd see this dotted line, and the plane would look like that. So a square is a pretty straightforward thing to get if you're doing a planar slice of a cube. But what about a rectangle? How can you get that? And at any point, I encourage you, pause the video and try to think about it on your own. How can you get these shapes that I'm talking about? Well, a rectangle you can actually cut like this. So if you cut this side like this, and then cut that side like that, and then you cut this side like that, I think you see where this is going, this side like that, and then you cut the bottom right over there, then the intersection of the plane that you're cutting with, so the intersection, let's see, this could be the plane that I'm actually cutting with. So the intersection of the plane that I'm cutting with and my cube is going to be a rectangle. So it might look like this, and once again, let me shade in the stuff. If you kind of view if you imagine the plane as like one of those huge blades that magicians use to saw people in half, or pretend like or give us the illusion of sawing people in half, it might look something like this. Okay, so you're like, okay, that's not so hard to digest, that I can, if I intersect a plane with a cube, I can get a square, I can get a rectangle. But what about triangles? Well, once again, and pause the video if you think you can figure it out. Triangle's not so bad. You could cut this side right over here, this side right over here, and this side right over here. And then and of course I could keep drawing the plane, but I think you get the idea. This would be a triangle, and there's different types of triangles that you can construct. You could construct an equilateral triangle. So as long as this cut is the same length as this cut right over here, is the same length as the length that it intersects on this space of the cube, that's going to be an equilateral triangle. If you pushed this point out more, actually let me do that in a different color. If you pushed it out more, you're going to have an isosceles triangle. If you were to bring this point really, really, really close, like here, you would approach having a right angle, but it wouldn't be quite a right angle. You'd still have, these angles would still be less than 90 degrees. You can approach 90 degrees, so you can't quite have exactly a right angle. And so you can't get to 90 degrees, you're definitely not going to get to 91 degrees. So you're actually not going to be able to do an obtuse triangle either. But you can do an equilateral, you can do an isosceles, you can do scalene triangles. I guess you could say you could do the different types of acute triangles. But now let's do some really interesting things. Can you get a pentagon by slicing a cube with a plane? And I really want you to pause the video and think about it here, because that's just a fun to think about. How can you get a pentagon by slicing a cube with a plane? All right, so here I go. This is how you can get a pentagon by slicing a cube with a plane. Imagine slicing the top. Let me do it a little bit different. So imagine slicing the top right over there. So we imagine slicing the top like this. But imagine slicing this backside. Imagine slicing this backside like that. And this backside that you can't see quite like that. Now you slice this side right over here like this, and then you slice this side right over here like this. This could be, like if I wanted to draw, well, the plane maybe won't be so obvious if I try to draw the plane, but you get the actual idea. If I slice this, the right angle, not at a right angle, at a right angle, actually I should use the right angle, that'll confuse everything. If I slice it in the proper angle, then I am with the intersection of my plane and my cube is going to be this pentagon right over here. Now let's up the stakes something. Let's up the stakes even more. What about a hexagon? Can I slice a cube in a way with a two-dimensional plane to get at the intersection of the plane and the cube being a hexagon? Well, as you can imagine, I wouldn't have asked you the question unless I could. So let's see if we can do it. So if we slice this right over there, if we slice this bottom piece right over there, and then you slice this backside like that, you slice this backside like that, and then you slice this side that we can see right over there, and then this side that we can see right over there. This side I could have written it much straighter. So hopefully you get the idea. I can slice this cube so that I can actually get a hexagon. So hopefully this gives you a better appreciation for what you can actually do with a cube, especially if you're busy slicing it with large planar planes or large planar blades in some way. There's actually more to a cube than maybe you might have imagined in the past. One way to think about it is there are 6 sides to a cube, and so are 6 surfaces to a cube. So you can cut as many as 6 of the surfaces when you intersect it with a plane, and every time you cut into one of those surfaces, it forms a side. So here we're cutting into 4 sides. Here we're cutting into 4 surfaces or 4 sides. Here we're cutting into 3. Here we're cutting into 5. We're not cutting into the bottom of the cube here. And here we're cutting into all 6 of the sides, all 6 of the surfaces, of the faces of this cube.
Have gotten that we can make a, the first thing he did was a square. Then he did a rectangle. Then he did a triangle. Then he did a pentagon. And then he did a hexagon. Those are all possible. Possible. Okay, so one thing I want to make sure that we touch on is a 4-sided figure. Doesn't just have to be a square or a rectangle. Okay, so be sure to understand that other 4-sided figures, okay, like a trapezoid, for example, are possible depending on the angle you enter and exit the cube. Okay, describe how other figures such as points or segments can be gotten from planar cuts of a solid such as a cube. Okay, so a point A point is gotten by cutting the corner or vertice of a prism. A segment is gotten by cutting the edge of a prism. Okay, so you can kind of visualize that here. If you cut infinitely close to this vertice here, you will have that point. And if you cut infinitely close to this edge, you will have a segment. All right, now we're going to take a look at how this applies to a rectangular prism. All right, I cut parallel to the base. Remember, that could be high or low. I don't know why this did not form. So the plane section will always be the same shape as the base of the prism. Okay, so if you've got this rectangular prism and you cut parallel, you're going to get the exact same shape of the base. Okay, so the plane section will always be the same shape and size of the prism's base. Okay, now perpendicular to the base, parallel to a face, something like that. Okay, what's true about this? The planar section will always be the same as the face of the prism. What is true about cuts of a rectangular prism not parallel to the base? Well, the plane sections will not be, or will not all, the same as the base. Okay, so let me show you a website that you can go to play with these if you're having a hard time visualizing these. So let me click over to this guy right here. Okay, take note of this web address, shodor.org/interactivate/activities/cross-section flyer. Okay, now you can change how many faces something has. So this is a cube, obviously, 6 faces, and you can make it be however many number of lateral faces that you want. The slice can be moved up, can be moved down, as we talked about it. Notice that's a parallel slice. And notice this is the planar section. And if you want it to identify it, okay, it should give you a name here. Okay, so we've got a triangle, no matter how we slice it, parallel. And then we start kind of tilting, coming in at different angles. And you can see how that affects things. So depending on how many sides you're entering and exiting, that kind of thing, depends on what you are getting. So notice that we're getting all sorts of different 4-sided shapes, all sorts. rectangle, quadrilateral, trapezoid. Okay, so let's look at our prism that is a rectangular prism. So this I can move and this I can move. Okay, and then this I can also move. So we were looking at straight, like perpendicular cuts here. Okay, so notice if I rotate it like this, I have all sorts of rectangles. Okay, and if I start rotating deep or not as deep within, I still have my rectangle. Okay, but the moment I start putting a slant to it, kind of determines what kind of a rectangle we're getting. Okay. All right, so please play with this website if you're having a hard time visualizing the 2D version that I'm presenting. Okay. All right, where were we? Oh, lost my space again. We were right here. Okay. So our next thing to think about is a sphere. All right, now if you cut parallel to the table, so I've got this thing, a sphere, ball of some sort sitting on a table. If I cut parallel to the table, do you see that I'm going to have different sizes of circles? Okay, the cross sections. So this would be like a cut here, a cut here, a cut here, a cut really close to the top. Those would be cross sections, will be circles of various sizes. Okay, if you make cuts that are not parallel to the table, aren't we going to have the same thing? I'm going to put these little quotation marks saying same thing as up here. Perpendicular to the table, aren't we going to have the same thing? Okay, cut perpendicular to the table again, but a different location. So we just already covered that with this. So if we get infinitely close here, we would still have that circle. Okay. Is it possible to get other figures such as points or segments when any planar cuts are made through a sphere? Why or why not? No, since there are no vertices or edges in a sphere. Okay, let me see if that website had a sphere option to play with. I don't see one here. So I only see pyramids, cylinders, cones. We will not be using double cones. That's more of a high school thing. Okay, so I don't see that you guys have a circle option on this. Okay, so our next shape that we will be looking at is a cylinder. Okay, so if you have a cylinder and you cut it parallel to the base, you will be getting that circle. Okay, so this cut would happen parallel to the base. The cross section will always be circles the same size as the base. not parallel to the base, but through the lateral face of the cylinder. Can you picture what that might look like? Okay, these will result in ellipses. Ellipses kind of look like ovals, kind of look like footballs in a way. You can think about stretched out circles. Stretched out circles. Okay, and depending if you cut into the side or if it's into the circles, you might get kind of a hard end like that with like a oval type edge on the other side. Okay, and then I cut perpendicular to the base. Any of these, you will have various sized rectangles. The result would be various sized rectangles. Okay, let's go into our interactive website. And let's get a cylinder up. And then let's make it a little skinnier like that. Okay, we're going to move the slice up and down. Do you see how this remains unchanged? The cross section is a circle. When we make parallel to the base slices. Okay, now this guy, hang on, let's do it this way. Okay, so if we're if we're vertically slicing through, you can see I get rectangles over and over and over and over again. Okay. Okay, now if that slices through the sides, let me spin that around so you can see how I'm cutting. It's going to have kind of like a harder edge to it, if that makes sense. Okay, so you can play, notice this says ellipse, okay? You can play with a cylinder if you need to. All right, the next shape we're going to look at is a triangular prism. This guy right here, okay? Kind of like a wedge of cheese, okay? Kind of like a doorstop. Okay, so it's very important to understand if it's sitting like this, it's not sitting on its base. This is its base because these are the two parallel sides. These are not parallel sides. Okay, this is its base. So if it's sitting like this, you need to picture it in your mind like this. Parallel to the base, okay, we would have triangles that are the same exact size and shape of the base. Okay, so you have to picture the cut like this. Okay, these will result in cross sections that are the same size and shape as the base. Okay, on number 19, cuts that are not parallel to the base but go through at least one face of the prism. Okay, so we can do lots of different kinds. Okay, these cuts will result in different sized and shaped polygons. Okay, let's do number 20 and then we'll go over to our interactive site. Cut perpendicular to the base. Straight down like that. Okay, but what if you are deeper within or not as deep within? These will be different sized rectangles, same height as the prism, but different widths. Widths, depending on where you made the cut. Okay, the interactive site to look at a triangular prism. Let's get back into our prism here. Let's make sure we're down to a triangular one. Let's look at, first of all, let's look at it parallel. Okay, so this guy, no matter how high or how low I am making a parallel slice to the base, this is always going to be a triangle. Okay, this happens to be an equilateral triangle because it is equilateral triangle at the base. Okay, it might not be equilateral at the base. It might be isosceles or scalene. Okay. All right, now if we rotate this to be perpendicular, notice that this is always going to be some sort of a rectangle. Always going to be some sort of a rectangle. Okay, but the moment that we have it at a slant, notice all these different shapes: rectangle, quadrilateral. I saw trapezoid in there. There's a trapezoid right there. Look at this four-sided shape. Okay, so all sorts of quadrilaterals can be formed depending where you slice. Okay. All right. Then we get into so on the bottom is a square, and this is a pyramid. Remember, pyramids have a base, one base, with triangles all formed around joining the edges, coming up to an apex. Okay, so if you make cuts parallel to this base, aren't you going to be getting different size squares? Okay, so you got to picture that like this. Okay, so these cuts will make different sized squares. Cut perpendicular to the base and parallel to one of the edges. Something like that. Okay, these cuts will result in different sized trapezoidal sections. Cut perpendicular to the base, but at a different location on the pyramid. Okay, so there's one option. So the plane sections will vary. Depending on how many faces cut into. Okay, so if it's perpendicular, it has to cut in to, what would that be? 1, 2, 3, 4 faces. So let's take a look at the interactive. Make a pyramid here. So let's click on pyramid and let's get down to a square one right here. Okay, let's try to be as horizontal as we can be. So I'm a little tilted. It should be square, shouldn't it? Okay, so I'm having a hard time getting that. Maybe I can line it up with that. Close. So almost. All right, so you're gonna have to just play with that and see how that works for you. Okay, so we got a lot of quadrilaterals, lots of trapezoids, lots and lots of trapezoids. Okay, so, ooh, that looks pretty, oh, square. I finally did it. Okay, that is a completely parallel slice to this thing. I've got my square. Okay, let's take that and go completely perpendicular. Okay, I've got this quadrilateral, depending how many, or what kind of where I slice through. Okay, got a triangle, okay, triangle, and then lots of quadrilaterals, lots and lots. Okay, so you guys can play here for that shape if you'd like to. Okay, and then we need to summarize this. This is very 7.2a. When you have a two-dimensional planar result of any parallel and perpendicular slices of prisms, it's really important to understand that parallel slices to the base. Okay, notice that this is prisms, will result in the exact same size and shape of that base. Okay, remember that is called congruent. Okay, perpendicular slices to the base will result in various sized rectangles depending where the slice is made. Okay, so let me give you an example. Given a triangular prism, any slice parallel, you're going to have a triangle. Any slice parallel, you will have a congruent triangle to the base. Perpendicular, slices will result in various sized rectangles. Okay, let's talk pyramid. Pyramid parallel slices to the base will result in various sized but proportional to the base. To the base. Perpendicular slices. Perpendicular slices will result in various sized rectangles. Keyword perpendicular. The moment we put a slant on it is the moment we start getting trapezoids, triangles, just different kinds of shapes. Okay, so picture let's take a square. Given a square prism, any slice parallel, you will create different sized squares. Perpendicular slices to the base will create various sized rectangles depending how deep you slice into the solid. Okay, those two, sorry, they're kind of messy. Those two are kind of the nutshells of prisms and pyramids, parallel and perpendicular slices you need to understand to the base. Thanks, guys.